Hello, welcome everybody to this video. This is a walkthrough for the code, the C# code. We're specifically in this video going to dive in and explore the code at a little bit more, I don't know, at a deeper level. What we're looking at here is our prototype 1 or our driving simulation project, and it is basically at completion at this point. Wanted to go back and look at the code. There are two basic scripts that we used: FollowPlayer, which we attached to the camera, and then player controller, which of course is attached to the player because it allows us to control. So scripts in Unity basically allow us to add behaviors, functionality, and control to various aspects of our game. And as we continue through the course, we'll learn more sophisticated programs, and we'll be using coding, I think, in more sophisticated ways. But at the start, it's largely to govern kind of the behavior of some of our game objects. So let's start with the first script that we did, which I guess let's follow the player. Actually, we bounce back and forth, but let's go into the follow the player script. Before we go into the script itself, though, I wanted to take a look here. If we locate our camera by clicking on the hierarchy, right, and we can hit F on our keyboard to frame in, you can see that we have the camera positioned here behind the vehicle. It's behind the vehicle and it's up above the vehicle. It's rotated slightly down, so we kind of get this over-the-shoulder perspective. Well, the follow player script, like the purpose of the script, is to govern the behavior of the main camera. And specifically, what we're doing is making a rule that says, hey, every frame, we want you, camera, to be exactly where you are in relation to the vehicle. So you need to be the same amount back and the same amount up as you are. And we can see in the inspector up here, if you come up to the transform up here in the upper right, you can see that the X is 0 because we want the camera to be directly behind the car. So it's not left, it's not right, it's at 0, just like the truck is at 0. And then in the Y, that's up, so I'm 4 units up. Now, in your particular project, it might be up a little bit higher. And then minus 6Z means it's behind. It's 6 units behind. Typically, Unity uses 1 meter as units. So it's about 4 meters back, or 6 meters back, excuse me, and about 4 meters up. And it's slightly rotated. But let's go take a look at the script here. So the script is called, this guy up here. What this script does, what programming is in Unity really is, we are using C#. But what we're doing is we're dipping into what's called an API, an application programming interface. There's a bunch of things that somebody has programmed specifically in this using Unity engine, which is kind of like a toolkit. So let's comment that here. Basically, a toolkit we can use to make things happen in games more easily. We don't have to program them from scratch. People have programmed a bunch of tools, and we need to, part of our learning process is learning what's in that toolbox. So for instance, game object is a data type that's in that toolbox. So it allows us to use game object as a type of variable. Now remember, a variable is basically just a container. It holds something, and it can hold the player in this case. It can hold a vector, which is something in 3D space, right? It's a force that's operating in the game. It could be a number, it could be a character, it could be a string of characters. So we can have variables that hold different things. So that's what this Unity engine is here. And then system collections are kind of the built-in kinds of things you can use in C#, but they're also sort of toolkits. All right, so let's talk about the structure of a program. A program in C# always consists of a class, and if you want somebody to use it, it's a public class, so that means it's accessible. The name of the class, okay, is generally in upper camel case. It's got a capital letter for each word and lowercase for the other letters in the word. So we can see the F is capitalized in follow, and it is capitalized in player. What does this guy here do? This guy here, the colon mono behavior, we wouldn't, if we were programming something in C# that was not in Unity, we wouldn't need this. This basically is like a tag here. So let's put the tag that we should be clear. It's the mono behavior. Mono behavior is a tag to let Unity know this program exists and does something in the game. Okay, so that's what that does. If you don't have the colon mono behavior, then Unity it's like doesn't even see the program. All right, so, and we know that public class FollowPlayer, a class is basically, we can kind of get into this later, it's a template for making objects, but in our case we're just looking at it and using it kind of as a program. Now C#, like other programming languages, have these little curly bracers. And these two curly bracers, the one at the top and the bottom, are used in order to contain. It's like a container to hold everything that's going to be in our program FollowPlayer. So all code inside this program must be within those two brackets. And if you got rid of this bracket down here, you would likely end up seeing this little red squiggly mark show up, and it's going to be like, hey, something's wrong here. The integrated development environment, the IDE, which is what we're using, Visual Studio, is trying to help us, kind of like a word processor with grammar check and spell check. It's trying to help us make sure we don't have a lot of errors. Up here, or usually right below the first bracket in our program, we actually use instance variables. These are variables that are going to be used inside the script, and we generally have to declare those before we use them. So I'm not sure why in the boilerplate it doesn't have a spot like instance variables up here. If I could make, wave a magic wand, I would have that be up here, this little comment. Like these comments are down here for the start and the update method. So this is where you create variables, and sometimes you just create the variable that you're going to use later. We use player down here, and so that's why we've created this game object variable. So it's a little box that basically can hold only game objects, and we're deciding to call it player. Okay, so create variable called player that can hold game objects. Now what's a game object? Well, our truck and our obstacles, for instance, are game objects. They're things that can be put in the hierarchy. So in this case we're looking like we want it to follow the camera, follow the player, so we have to make a reference to the player to be able to for the script to know what to look at. Private vector 3 offset. Offset's the name of our variable. Although, by the way, public means that it shows up in the inspector. We can see it in the inspector, whereas private means we can't. Okay. So private vector 3 offset. Vector 3 is the type of data that's being held in this variable. Offset's the name of the variable. And in this case, what we're doing is we're actually initializing it. This means we're putting a value in it. So right here, public game object player is empty. We're not putting anything in it right now. And then private vector 3 offset, we've called it offset, just like player is the name for the variable here. This one is a box that can hold vector 3, right? So vector 3s are vectors in 3D space. They have an x, a y, a z in there, exert some force in that direction, okay? All right, so in this case what we're doing is we're saying we're assigning, and C# equal is an assignment operator, meaning it says put whatever's in the right into whatever is in the left. So that's what that equal sign is doing. Okay, and then whenever we declare a new vector, we have to write new. It's just a C# keyword that says, hey, we're about to create something, and C# and Unity in particular, that's where vector 3 comes out of this toolkit. And so vector 3, we're going to say, hey, we want in the x direction, we want no force. In the y direction, we basically are at 5 units. And in the z direction, we're at -7. So a vector, oops, I need to put 2 slashes. So the 2 slashes there means that it tells the compiler, any of this green stuff, it says ignore. So the compiler ignores anything after these 2 slashes. Okay. So here this comment is going to be create variable called offset to hold vector and put a hold it vector 3 and assign. We'll use assign a value. So it's assigning a value, okay, and the value happens to be 0, 5, -7. So We'll be using vectors, vector 3s a lot, and so you'll get more comfortable with that as you go. All right, so this method, so these guys are like what instance variables, a way to think about instant variables are what a program can know. All right, and then methods, there's a void method and a void start method, excuse me, and a void update method, and both of these methods are kind of like behaviors. They're what a program does, so they're like actions. So kind of what you know and what you can do. So public variables, this is what we know, okay, and this is what we can do, and then this is what we can do. Now, for the start method, we've got a comment here already, so this is a reminder in our kind of boilerplate that it gives us, that little template. Start is called before the first frame. It's only called once. So if you need something to happen only once, that's where you put it. And just like the program has these bracers, method, each method has bracers, and you put the code in between those bracers. Okay. So in this particular case, we don't need it to do anything at the start. We want to put it into the void update, the method update. Okay. What does void mean? Void means that this method is not going to return a value. You can have it so that a method does something and then returns a value, like some sort of number or string, characters, a vector, a game object. It can return anything. But when you say void, and then it means that it's not returning anything. So we'll talk more about that and get more into what void does a bit later. We're not going to be using methods that return anything for a little while. All right, so update is a method, a behavior. It gets called every frame. So it is basically like the game loop. As the game is played until the game stops, it will execute each line of code in here once every frame. Okay. So again, it has brackets like all methods, and we need to make sure that our code is in between these brackets. So finally, let's look at our line of code. This is doing a lot of the actual work here. We're attaching our script FollowPlayer to the camera. So because it's attached to the camera, when we say transform, and every 3D object in 3D space, every object in 3D space has a transform, and it has a transform position, a transform rotation, and a transform scale. And that determines, the position determines where in 3D space it is. So there's going to be an X, a Y, and a Z coordinate in 3D space, right? The center of 3D space is at 0, 0, 0. So what this is going to do is it's going to say, hey, go get where the camera is at. Get the X, Y, and Z of the camera. Okay, get the position of the camera. So because there's nothing here in front of the transform, it assumes that it's whatever we've attached the script to. So in this case, that's the camera. Equal, it's basically assigning a value. It's saying, hey, you know what? I want you to change this transform dot position of the camera to whatever's on the right side of the equal. Here we've added player, and we created player up here in the top with our game object. We created a variable for it. So we're saying, hey, we want to set the camera transform position to the player transform position. Okay. Now the script doesn't know exactly what the player is. We're going to have to go in and basically put a value in here to let the script know which object is the player back in the Unity interface, the Unity editor. But we also don't want to just put it where the player is, right? Once we connect the player to the script, then it would be inside the vehicle. The camera would be inside the vehicle because it's at the same exact position. We want it at the player position plus the offset, meaning we want it to be centered in the X right behind the player. We want it to be, in this case, 5 units in the Y, which means it's going to be above the player, okay, and it's going to be 7 units back from the player, okay. So we basically are telling it this, the offset is the distance. If we go back to here, this is the distance if we're looking at our, camera, it's the offset is the distance back, and the Z, that's the negative number, and then up, and the Y, that's the positive number, and it's not changing left to right. Okay, so that's a pretty solid walkthrough of the FollowPlayer script. Let me know if you've got any questions here. Let's finalize this by saying set the camera position, that's what transformed opposition is, to be the same as the player position but offset by the offset vector 3. Okay. All right. So hopefully that helped clarify things with the code and helps you get a little bit more comfortable with what's going on in the code. Definitely reach out to your instructor if you've got any questions. And I thank you for your time and attention, and I'll see you in the next video.